All right, let's talk about dative bonds. I know, that's a topic that can make a lot of students nervous when they're prepping for the SPM Chemistry paper, but you've come to the right place. It might seem kind of tricky at first, but I promise you, by the end of this little explainer, you're going to feel so much more confident about it. We're going to get this mastered, together.
Okay, but before we dive deep into the chemistry, let me give you a pro tip. Look, the absolute best way to make sure all this information actually sticks is to practice. So, go ahead and scan this QR code or just head over to www.mcqspm.com. You can even grab the MCQ SPM app. Seriously, they're loaded with past year questions, which is exactly what you need. It's perfect for testing yourself after we're done here. All right, you ready to do this? Let's get started.
Okay, first things first. Section 1. What is a dative bond? Let's break down the basics. So let's just ask the big question right off the bat. What exactly is a dative bond? You've probably spent tons of time learning about regular covalent bonds, right? So what makes this one so special? Let's dig in.
Okay, here it is, the textbook definition you absolutely need to know for your exam. A dative bond, and you might also see it called a coordinate bond. They're the same thing, is basically a special type of covalent bond. But here's the twist, and this is the most important part. The shared pair of electrons comes from only one of the atoms. Not one from each, but both from one. That's it. That's the secret sauce right there.
I love this analogy because it makes things so clear. Think about it like sharing lunch with a friend. A normal covalent bond, that's when you both bring a sandwich and you share. Fair is fair, right? A dative bond, though, that's like your friend showing up with a whole picnic basket for both of you because you forgot your lunch. Your friend is the donor atom, bringing the entire electron pair to the table. But you both get to share it. One atom is super generous, but both end up happy and stable.
All right, Section 2, dative versus covalent bonds. What's the difference? To make sure you don't get tripped up in the exam, let's really put these two side by side and see what sets them apart.
This little table here just breaks it all down perfectly. Look at the electron source. For a standard covalent bond, it's a team effort. Both atoms pitch in. But for a dative bond, nope. Only one atom contributes. It's not a 50-50 split, it's a 100-0 deal. One atom donates a whole lone pair. Keep this comparison in mind, because it's the key to spotting the difference when you're under pressure.
Okay, Section 3, seeing it in action, forming key ions. Theory is great and all, but this is where the magic happens. Let's look at a couple of real-world examples, two ions that you will almost certainly run into on your SPM papers, so pay close attention.
And first up, we have a real celebrity in the world of acid-base chemistry. Let's see how the hydronium ion, that's H3O+, is formed. So how does this happen?
Well, first, you've got your donor. In this case, it's a good old water molecule, H2O. See, the oxygen atom in water has two lone pairs of electrons just hanging out, not involved in bonding. It's ready to share. Then along comes our acceptor, a hydrogen ion, H+. This poor little guy has an empty electron shell and desperately needs two electrons to be stable. So what happens? The water molecule, through its oxygen atom, donates one of its lone pairs to the hydrogen ion. And boom, a dative bond is formed, and we get the stable hydronium ion. Simple as that.
Got that? Great. Now, let's look at our second classic example, the ammonium ion, NH4+. And you're going to see it's pretty much the same story. It really is the same play, just with different actors. This time, our donor is an ammonia molecule, NH3. The nitrogen atom in the middle has a lone pair of electrons, making it the generous friend. And our acceptor? Well, it's that hydrogen ion again, H+, still looking for two electrons to become stable. So the nitrogen in ammonia donates its lone pair to the H+ ion. And what's the result? A dative bond forms, creating the ammonium ion, NH4+. Are you seeing the pattern here? You've got a donor with a lone pair and an acceptor that needs a pair. It's a perfect match.
Okay, let's move on to the part that really matters, right? Turning all this knowledge into actual marks on your exam paper. Section 4, cracking SPM exam questions. Let's try to think like an examiner. All right, check this out. This is a real question from the SPM Colanton paper in 2021. The diagram shows a reaction between ammonia, that's NH3, and boron trifluoride, BF3. The question is simply, what chemical bond is formed here? Take a good look at that diagram. What do you see?
So, how do we tackle this? Let's use a strategy. Step 1, identify the players. We've got ammonia and boron trifluoride. Easy. Step 2, and this is the most critical step, look for a lone pair. Your eyes should immediately go to the nitrogen atom in ammonia. See that pair of dots? That's our lone pair. That's our donor. Step 3, look for an electron-deficient atom, our acceptor. The boron in BF3 is the perfect candidate. It can accept an electron pair. So step 4 is just connecting the dots. The lone pair from nitrogen is donated to the boron. And what do we call that? It's a classic textbook dative bond formation. See? Not so hard when you have a system.
You know, the most common mistake I see students make with questions like this is that they just don't spot the lone pair donor. They get overwhelmed by the diagram, but you have to train your brain to look for it first. Think of that lone pair as a giant, flashing neon sign pointing to your answer. Find the donor first, and the rest of the puzzle just falls into place.
All right, that was a lot to take in, I know. So let's wrap it up with a quick summary. This is your Dative Bond cheat sheet. All the key takeaways in one place.
Okay, when you're doing your final revision, here are the absolute must-know points. 1. A dative bond is a type of covalent bond. Don't forget that. 2. One atom, and only one, donates both electrons for the bond. 3. Your game plan in an exam is to find the donor atom with a lone pair, think oxygen and water or nitrogen and ammonia, and then find the acceptor atom that can take those electrons, like H+. And finally, lock in those 2 key examples we talked about, the hydronium ion and the ammonium ion. You will see them again.
And there you have it, dative bonds, totally demystified. So I'll leave you with one last question to chew on. Now that you know how it's formed, now that you can spot this pattern of a generous donor and a willing acceptor, can you think of other molecules or ions where a dative bond might be the silent force holding everything together? Something to think about. All right, that's all for now. Good luck with your studies, and thanks for listening.